Good morning, myself Manwinder Kaur, lecturer chemistry. Today my topic is general metallurgical operations. First is history of metals. The use of metals is said to be the thing that makes people different from animals. Before they used metals, people made tools from stones, wood, and animal bones. This is now called Stone Age. No one knows when the first metal was found and used. It was probably what is called native copper, which is sometimes found in large lumps on the ground. People learned to make this into copper tools and other things, although for a metal it is quite soft. When it was melted over fire, people learned how to make an alloy called bronze, which is much harder and stronger than copper. Bronze is much harder and stronger than copper. People made knives and weapons from bronze. This time in human history, after about 3300 BC, is often called Bronze Age, that is the time of bronze tools and weapons. Now, what are metals, non-metals, and metalloids? Most periodic tables contain a stair-step line which allows you to identify which elements are metals, non-metals, and metalloids. Metals and non-metals. Elements that border on amphoteric line, this green line, they are metalloids. They have characteristics of both metals and non-metals. Aluminium, Al, however, definitely has mostly metallic character, but boron, it is mostly non-metallic. All these are metals, and here these are non-metals. Metals, they have luster, they are malleable and ductile. They conduct heat and electricity. Fourth point, they tend to lose electrons. Non-metals. Non-metals are dull. They are brittle. They do not conduct heat and electricity. They tend to gain electrons. Metals. Most elements are metals. 88 elements to the left of the stair-step line are metals or metal-like elements like copper, aluminium. Picture of metals: copper, nickel, manganese, chromium. These are some most reactive metals like sodium, calcium, and magnesium, and these are some least reactive metals. Physical properties of metals. First is luster, shininess. Second point, they are good conductors of heat and electricity. Third point, they have high density, that is heavy for their size. Fourth point, they have high melting point. Fifth point, they are ductile. Means ductility means most metals can be drawn out into thin wires. Malleable, it means most metals can be hammered into thin sheets. Ductility means most metals can be drawn into thin wires. Malleable means most metals can be hammered into thin sheets. Chemical properties of metals. First point, they easily lose electrons. Second point, they corrode easily. Corrosion is a gradual wearing away. For example, silver tarnishing and iron rusting. Major toxic metals are chromium, arsenic, lead, mercury and nickel. Minor toxic metals like iron, zinc, selenium. Essential metals with toxicity are aluminium and gold. Metals with toxicity related to medical therapy, for example, barium. These are non-metals. Non-metals are found to the right of the stair-step line. Their characteristics are opposite those of metals. Non-metals, they are found to the right of stair-step line. Their characteristics are opposite those of metals. Pictures of non-metals, for example, bromine, fluorine, chlorine, astatine, iodine. These are non-metals. These are also non-metals, bromine. Physical properties of non-metals. First is no luster, means they are dull in appearance. Second point, they are poor conductor of heat and electricity. They are brittle, means break easily. Non-ductile, non-malleable and they have low density. Non-metals, they are dull in appearance. They are poor conductor of heat and electricity. They break easily. They are neither ductile nor malleable and they have low density. What are the chemical properties of non-metals? Tend to gain electrons. Since metals tend to lose electrons and non-metals tend to gain electrons, metals and non-metals like to form compounds with each other. These compounds are called ionic compounds. When two or more nonmetals bond with each other, they form covalent bond. When two or more nonmetals bond with each other, they form covalent compound. These are some nonmetals. Metalloids, elements on the both sides of zigzag line, have properties of both metals and non-metals. These elements are called metalloids. Elements on the both side of zigzag line have properties of both metals and non-metals. So these elements are called metalloids. These are the pictures of metalloids. Physical properties of metalloids. They are solids. They can be shiny or dull. They are ductile, malleable, conduct heat and electricity better than non-metals, but not as well as metals. Difference between metals and non-metals. First point, metals are generally solids except mercury and gallium. Metals are generally solids except mercury and gallium. Metals are heavy except sodium, potassium and magnesium. Metals are hard and non-brittle except sodium, potassium, lead, which are soft. Non-metals are found in all three states. Metals are generally solids, but non-metals, they are found in all three states. Non-metals are generally light in weight. Non-metals are hard but brittle. Metals are good conductor of heat and electricity except lead. Non-metals, they are bad conductor of heat and electricity except graphite. Metals are ductile and malleable. Non-metals are neither ductile nor malleable. Metals, their melting point and the boiling points are generally high, but in case of non-metals, their melting point and boiling points are generally low. Metals produce ringing sound on collision. Metals, they produce ringing sound on collision. Non-metals, they do not produce ringing sound. Metals are lustrous and can be polished. Non-metals, they are non-lustrous and can't be polished. Occurrence of metals. Metals and their compound are found in earth as natural elements known as minerals. What are minerals? Metals and their compounds, they are found in earth as natural elements and they are known as minerals. Next is ores. Ores are minerals from which metal can be extracted economically and profitably. Ores are minerals from which metal can be extracted economically and profitably. Ores contain metal compounds with a low percentage of impurities. All the ores are minerals, but all the minerals are not ores. All the ores are mineral, but all the minerals they are not ores. Occurrence of metal in nature in free state and in combined state. In free state, the metals that occur in free state are, for example, gold, platinum, silver, and mercury. In combined state, sodium, calcium, potassium, aluminium, lead, and copper. Occurrence of metals in free state. Very few metals exist in free or native state. Very few metals exist in free or it is also called a native state. Only metals like gold, platinum and mercury they are found in free state, means in the pure form. Sometimes copper and silver may also be found in free state. Such metals are not acted upon by air or water. In combined state, rest of the metals occur in combined form as compounds such as oxides, carbonates, sulfides, sulfates, silicates, chlorides, nitrates, and phosphates. Copper and silver are the two metals which occur in free as well as combined state as sulfide, oxide, or halide ores. Metals at the top of the activity series, for example, potassium, sodium, calcium, magnesium, and aluminium, are so reactive that are never found in nature as free elements. The metals in the middle of the activity series like zinc, iron, lead, Pb, they are reactive. They are found in the Earth's crust as oxides, sulfides, or carbonates. Minerals. The natural substances in which the metals occur either in native state, means free state, or combined state are called minerals. The natural substances in which metals occur either in native state or free state or combined state, they are called minerals. The most common forms of metals in the combined state are oxides, carbonates, sulfides, and silicates. Ore. Ore means that a mineral or an aggregate of minerals from which a valuable constituent like metal can be extracted profitably. An ore is a material that contains a metal in such quantities that it can be mined and worked commercially to extract that metal. The metal is usually contained in chemical combination with some other elements in addition to various impurities. Types of ores. First is native ore. These ores contain metals in free state. Native ores, they contain metals in free state. For example, silver, gold, platinum, mercury and copper. These are found usually associated with rock or alluvial material like clay and sand. Sometimes lumps of pure metals are also found. These are called as nuggets. Second is oxide ore. In these ores, metals represent their oxides or oxysalts such as carbonates, nitrates, sulfates, phosphates and silicates. Halide ore. Metallic halides are very few in nature. Chlorides are most common. Metallurgy. Metallurgy is a domain of material science that studies the physical and chemical behavior of metallic elements, their intermetallic compounds and their mixtures, which are called alloys. It is also the technology of metals, the way in which science is applied to their practical use. Metallurgy is commonly used in the craft of metalworking. It is used in the craft of metal working. Based on the Longman Dictionary, the word origin of metallurgy is metallurgia. From Greek metallon means metal, argos means working. So, according to its base, metallurgy means metal working. Metallurgy means metal working. Extraction of metal from their ore. There are 4 steps for the extraction of metal. First is crushing, grinding or pulverization. Second is concentration of ore. Third is conversion of concentrate to oxide, and the fourth step is the refining of metal. Concentration of the ore is done by 2 methods, chemical and physical method. Physical methods are magnetic separation, hydraulic washing and froth flotation. Chemical methods are leaching, Second is conversion of concentrate to oxide. This is done by two methods. First is roasting and second is calcination. Refining of metals is done by liquefaction, electrolysis and distillation. What is gangue or matrix? Ores usually contain soil, sand, stones and other useless silicates. These undesired impurities present in ores are called gangue or matrix. The earthy impurities like soil, sand, stones, these undesired impurities that are present in the ore, they are known as gangue or matrix. Now, what is concentration of the ore? The removal of these impurities, the removal of earthy impurities from their ore is known as concentration. Before the ore is subjected to concentration, it is crushed into small pieces in gyratory crushers. The crushed ore is then grinded with the help of rollers or in the stamp mills to powder form. These impurities can be acidic or basic. Acidic impurities like SiO2, P2O5 or basic impurities like calcium oxide CaO and MgCO3, magnesium carbonate. What is flux? Flux is a chemical cleaning agent that facilitates soldering, brazing and welding by removing oxidation. Common fluxes are ammonium chloride, hydrochloric acids and borax. What is flux? The substance which is added to the ore to remove acidic or basic impurity is called flux. Flux is a substance which is added to the ore to remove acidic or basic impurity is called flux. These are of two types, acidic flux and basic. Acidic flux like SiO2 and P2O5. Basic flux like CaO and magnesium carbonate. What is slag? The fusible mass formed by the combination of flux and impurities is called slag. The fusible mass formed by the combination of flux and impurities means gangue is called slag. Flux plus gangue, slag is formed. Types of metallurgy. First is pyrometallurgy, second is electrometallurgy and third is hydrometallurgy. First is pyrometallurgy. It is the process of extraction of metal from their ore by heating. The process of extraction of metal from their ore by heating is called pyrometallurgy. For example, iron is extracted from ore hematite by pyrometallurgy. So, pyrometallurgy is the extraction of metal from their ore by heating. Picture of pyrometallurgy. What is hydrometallurgy? It is the process of extraction of metal from their ore by dissolving